today we're going to do a little bit of focusing. Yes, we're going to focus on that right there. Just look at it. We'll do that for an hour and 40 minutes and then see what you think. Sound good? All right. Now we are going to go straight to 5.6. Yes, this will be on the test. But it's not going to be a huge portion of the test. All right?
Well, yeah, your last test was only 13 questions.
This one will probably make up 1 or 2 problems. So 5.6. Let me say this. For 5.5, no homework. You don't need to do homework on 5.5. Now here's why. We kind of already did this when we were doing the synthetic division. That section kind of goes and talks more about that synthetic division. And I will allude to what that section is about as I'm doing today's stuff, which is 5.6. And this is complex zeros. Oh. Also, this section deals with the fundamental theorem of calculus. Algebra, wrong class. Yes. I'm being told that they're possibly already there. In the old stuff?
Yeah, the old stuff, sorry.
Take a look. They should be. I'll check after class. If they're not, I'll put them out there. Yeah, that file, this file is in Canvas already under my old exams and reviews. This is there, so the answers are probably there. They may not be. So if they're not, I'll get them on there. All right, so we're going to talk about 2 different things. Complex zeros and the fundamental theorem of algebra. They are very much connected to each other, all right? So let's first revisit this whole idea of a complex number. A complex number is any number that looks like this. A plus bi, where A and B are real numbers. Now, when we say real numbers, I'm talking about the numbers you've known your whole life, the numbers that come off of the number line. 1, 5, -10. Any number that you can pretty much think of, all right? Except for having that I in there. Okay, that I is different. The I is not a real number. The I is what we call, anyone remember what the I is? I is the imaginary number, or imaginary unit. It's called the imaginary unit. And specifically, I'm just turning my phone silent. Okay, 10 points, 10 points. The imaginary unit I is defined to be the square root of -1. So if you try and take, we know that if you try and take the square root of a negative number, we always say that, that's not a real number, right? Not a real solution. But if we're allowed to throw the imaginary numbers into this, then the square root of -1 is actually something. It's I. It's the imaginary unit. Okay? So here are some examples of imaginary numbers, or complex numbers. You tell me, is this a complex number? Yes. 3 plus 4i.
Yes.
Yes? Okay. The number in front right here, this is called the real part. And this right here, the 4, is called the imaginary part. All right? So is this a complex number?
No.
Okay. How about 7i? Yes? That's still a complex number? Okay, if it's a complex number, it must have a real part and an imaginary part. So the real part is 0 plus 7i. Good. So the real part of this number is 0. The imaginary part of this number is 7. With me?
Yeah.
Okay. Is this a complex number?
Yes.
Maybe.
Maybe.
It's plus 4i squared.
What if it's plus 0i?
I like it.
Isn't that the same thing?
Yes.
So 4 is actually a complex number. The real part is 4. The imaginary part is what? 0.
Why you gotta ruin all the other numbers for us?
So if you look at it this way, every single number you've ever known is actually a complex number. What's wrong?
You've been taught wrong your whole life.
What?
I know. So why is 4? Wait. So why is 4 plus?
To be a complex number, all you have to do is be able to be written in that form. Okay? So 4 equals 4 plus 0i is written in that form. And the real part is 4, the imaginary part is 0. But that still qualifies as a complex number, right? So if you look at it this way, every number that you've ever learned is actually a complex number, isn't it?
Yeah.
Every number. So you can kind of look at it this way. If you look at all the real numbers, right?
Are all complex but not all complex or real?
All of those real numbers belong to a bigger group of numbers called the complex numbers. It's a set. It's a set. It's a blob of something, right? So we have all the real numbers live in this set, right? But every real number lives in a bigger set, which is the complex numbers. So if you're a real number, like the number 4, you are real, but you're also complex. But if you're a complex number, like 7i or 2 plus I, these are complex numbers, but they are not real numbers. Understand? So anytime we've said there's no real solution, what we've meant is there's no solution in here that's going to work for us. I'll give you a very basic example. X squared plus 4 equals 0. When we're trying to solve that equation, we would maybe move the 4 to the other side, and then we would take difference of squares. I mean, sorry, square root, what the hell? I don't know where that came from. Plus or minus square root of negative 4. The weekend's still lingering into today, sorry. All right, so plus or minus, right, when you take the square root, and then negative, and then we would say not a real solution, right? Can't do this. What we meant was there's no number in here, no real number that's going to work. But there is guaranteed a complex solution. 2i? So where do you get the 2i from?
The square root of 4 and then the negative.
All right, yeah, so let's look at this right here. The square root of negative 4 is the same as the square root of negative 1 times the square root of 4, because that's how we split radicals up. Negative 1 times 4, right? Negative 1 times 4 is negative 4. And we just said the square root of negative 1 was I, and the square root of 4 is 2. So we write this 2i, but we had plus or minus here. So the two answers are actually plus or minus 2i. So there were two answers, weren't there? Yes? If we limit ourselves just to the real numbers, there are no real solutions. But if we allow ourselves to look into the complex numbers, then there are two solutions, aren't there? With me?
Yes.
Okay. The fundamental theorem of algebra, which is what this section is about, says that if you have a polynomial, I'm going to put it up here, the fundamental theorem of algebra says that if you have a polynomial function equal to 0, right? P of x is a polynomial, not a rational function, right? A polynomial. If you have a polynomial and you set it equal to 0, and the degree of the polynomial is n. So what was the degree of the polynomial again? It was the, It's the highest one, right? The largest exponent. The fundamental theorem of algebra says that we must have n solutions. We have to have n solutions. Like, what was the highest power when I had this polynomial here, x squared plus 4 equals 0? What was the power on the left-hand side of this polynomial? 2. How many answers did we have? 2. Fundamental theorem of algebra says that you will guaranteed have however many that power is. Right? So the conclusion here is then there will be n solutions. Some may repeat. Let me give you an example of one that repeats, okay? Something that would repeat. So if we had something like x squared plus 4x plus 4 equals 0, couldn't we factor this to be x plus 2 times x plus 2? Yes? And so we would get, what would our solution be? They're both pluses, so x would be negative 2. So here you might say, well, wait, this was 2, but I only have one solution, right? Right? 2, but only one solution? What? Because there's 2 factors, it repeats.
So technically, it's 2, but you make
That's right. It's a repeated solution. That's what this is saying. You should have n answers. Some of them might be repeated, so it may look a little different. The number of answers may not match this exactly, because some of them might be repeated. The number of factors, though, will definitely be the same as this. So x plus 2, 2 factors, 2 up here. The thing is, you can't have 3, all right? So if this is squared, there's no way to get 3 answers. Guaranteed. You with me? What today is about going back and looking at polynomials where we got stuck in certain things we couldn't factor and figuring out a way to find factors. But now we can include the complex numbers. That sounds like a great thing. Okay, so do you remember that problem you asked me about just a little while ago? You were asking about graphing it. It was like x minus 1, x, do you have it there?
Yeah. X minus 1, x plus 4.
Okay, give me the polynomial that started from.
Oh, x to the 4
Uh-huh.
plus 3x cubed plus 12x minus 16.
Okay, this was a problem out of the 15 problems. Which number was it? It was the first one? Okay, so if you're asked to solve this, what we want to do now is try and break it down completely, like solve it, including any complex solutions. So you did synthetic, right? What worked on synthetic? What was the first number that worked? 1? So we use 1 out here, right? No, I didn't put my 0. Easy, easy. Now that would have been a complete disaster, wouldn't it have?
I did that the first time.
You did that also? All right.
I forgot this.
All right, so when you do this, you get 1, 4, 0 here, right? 0. And then you're left with x minus 1. And then here, x squared or cubed? X cubed plus 4x squared plus 4x plus 16. Did you do synthetic again, or did you do grouping?
No, I just did the synthetic again.
You did synthetic again? Okay, if you did synthetic again,
It wouldn't work until negative 4.
until negative 4? Okay, so let me do that. 1, 4, 4, 16. It worked with negative 4? 1, negative 4, 0, 0, 4, negative 16, and 0. So you got that?
I totally shut up.
Okay. So let's see. Then we're going to have a slightly different answer. It's going to be x. This is going to be a different answer than what you got, isn't it? This right here? What does this turn into? X squared plus 4, right? You all following me on this? Okay, so these pieces right here just replace this right there, right? So going back to the original problem, when I set this up and I rewrite that, I have x minus 1. Then I have x plus 4. And then I have x squared plus 4 equals 0, don't I? And we would say, like if this problem was to sketch or something like that, we would say this piece doesn't have any role in the sketch, does it? It doesn't, right? This part. These two are our two x-intercepts. But if I'm trying to solve this now and get answers, and I'm allowed to include the complex numbers, then I do need to be able to figure out the solutions from this. I should get two solutions from that. So let me take that factor, or take each factor and set them equal to 0. All right, that's what you would normally do, I hope. You get 1 here. Is 1 a real number? Yes. Is 1 a complex number? Yes. Yes, but it's a real number, so I have a real answer. X is negative 4. Okay. And then this one, you would have to move things over. You get x is equal to plus or minus 2i. We just did that problem? And so that means you have two other additional answers, 2i and negative 2i. So if you were asked on this problem to solve it and include all complex solutions, then you would have a total of how many answers here? 4, right? 1, 2, 3, 4. But in terms of the graph, these would not play any role in the graph. No, because where do you put 2i and negative 2? They don't have a place. Yes?
So in the test, if they do in fact ask to add all complex numbers, we will have to include the 2i.
Yes. Now look at the review. Look at numbers 10, 11, and 12 on the review. When I say, you have the review, right? Yes? Number 10, find all, capital A-L-L. The solutions to this equation. What I mean is include the complex solutions, everything. See, that's why it's at the end of the test, because that's the last topic we're talking about here. So let's try, you want to try one of those?
Sure.
You know what, I want something a little more interesting. All right, we can do one. In case the solutions to that aren't online. That one's too easy. I'm gonna give you something else. I'll maybe get to those in a second. Solve x cubed minus 1 equals 0. Let's make it x cubed minus 8. There we go. So look, everyone, according to the fundamental theorem of algebra, we should have how many solutions to this? 3. Now, some of them could be repeated, right? But we know that it should factor into 3 separate pieces, right? Like this. This should turn into 1, 2, 3 equals 0. That's what it should do. That's what the fundamental theorem of algebra gives us. Some of these might be the same, yes? Okay. So when you look at that and you try and factor it, you have to first remember the difference of cubes formula. Do you remember seeing that at some point in your life? Okay, so the difference of cubes formula goes like this. X cubed minus y cubed equals x minus y times x squared plus xy plus y squared. That's the difference of cubes formula. For us, 8's a perfect cube, isn't it? It's 2 cubed, 2 times 2 times 2. So for us, the y in this formula is 2. Just needs to be replaced with 2. Yeah? So let me rewrite this. This becomes, you tell me, x minus 2. Okay, that's x minus y. And then x squared plus x times 2, or 2x. And then plus, what? 4 equals 0. Questions? We're not done yet, are we? No. We need to figure out what happens to this. And I told you last class that this guaranteed will not have any real solutions. If you ever use the difference of cubes formula, the quadratic that comes out of the formula will never have any real solutions. But it will, guaranteed, have complex solutions. Why does it have to have complex solutions? Because the fundamental theorem of algebra says that we need to have be able to get this into 3 factors, which means this has to factor somehow. So this is how we're going to do it. We're going to take this, set these each equal to 0 like we normally would, like this. The first one is 2. Is that a real number? Complex number? Yes. So I have one solution. It's a real number, but it's also a complex number. This one, the only way you're going to do that, because it doesn't factor, is the quadratic formula. So do you all remember the quadratic formula?
Minus b plus or minus
Yeah.
b squared.
That thing.
What she said.
I had a student in one of my other classes, in my Calculus 2 class, who got a tattoo of a mathematical thing on his arm.
I bet he was your new like teacher.
No. I just, you know, he was showing it to me. It was on his arm.
He has that on his arm.
What's that?
Is that cheating if he has?
No, that's why I'm bringing this up. If you ever want to get a permanent tattoo on your body with any mathematical formula, you are allowed to use that on the test. Okay?
Don't tempt me like that.
You're going to come all tatted up. It can't be that temporary one, though. It's got to be the permanent one. Got to carry for the rest of your life. All right, so let's plug into the formula here. X must be equal to what?
One day my son's gonna ask me.
Negative 2. Y'all need to practice this, okay? Because this is where a lot of students get hung up. You know, they know the formula, but they have trouble plugging it in. So what's going to go here? 4. 2 squared. Minus 4 times A, which is 1, times C, which is 4, all over 2 times 1. So what underneath the root? It turns into what? 4 minus 16? This is going to turn into 4 minus 16, which is negative 12. All right, so here's where I'm at. X is equal to negative 2 plus or minus the square root of 12, negative 12, all over 2. We good? Now, anytime you see a negative under a square root now, you know that the negative can go away and an I will appear outside the root. So this is going to turn into negative 2 plus or minus I root 12 over 2, which is negative 2 plus or minus 2I root 3 over 2. What just happened? Oh my gosh, what just happened? Yeah, root 12 is root 4 times root 3, isn't it? And so when you break up 12 is 4 times 3. The square root of 4 is 2. So there it goes next to the I. And then the root 3, you can't break it down. There's one more thing we can do. We can reduce everything by a factor of 2. So 2 goes into 2, 2, and 2. That goes in 1, 1, and 1, which leaves me with negative 1, right? Negative 1 plus or minus I root 3. I'm sorry?
I was just asking if you needed the 1.
You don't have to write 1, no, because of the i's there. You could also write this. But if you write it this way, be very careful because the I is not underneath the root. The I is separate. There's like a multiplication there. That's why we normally like to write the I out in front, so you don't accidentally think it's underneath the root. Is that all right? Okay, is this a complex number? Is it a real number?
No.
No. Okay, if it's a complex number, what's the real part? -1. What's the imaginary part? Square root of 3. Square root of 3. Right? Now there's actually two answers here, aren't there? There are two answers. The two answers are x equals -1 plus root 3. The other answer is x equals -1 minus root 3. Yes, write them both out.
So we're just forgetting about the I?
I forgot the I. Put the I.
We are forgetting about the I.
We are forgetting about. I am forgetting about the I. I know, it's a rough start to the week here. Right here? Personally, in most books, we'll use the top one. This one's not wrong. The only reason I wrote it like this is so it would match the standard form of a complex number, a plus bi. There's your b, there's your a. That's just to show you it, that's all. All right, we're okay? We're not done with the problem. I'm going to show you something. We have two of the solutions. What was the third one? We did a long time ago, right? X was what? X was 2. All right, so those are our three answers, right? That would be what I would want on the test. Those three answers. But I want you to see something, because there's something else that you're going to be asked to do that you won't understand unless I show you this, all right? All right, so let's go back now. Let's reconstruct where these came from. The x equals 2 came from what factor? X minus 2, right? It was the opposite. We always did that. Whatever number was here, we took the opposite of it and put it here, and that's from the factor to here, yes? If we go from here back to the factor, we just change the sign. With that same kind of mentality, couldn't I create these two also? Okay, it would be x, and then the opposite of what I see here. So let me see. How about this? Could I do this? X minus -1 plus root 3i. Does everyone agree? Lily, you can't answer for everyone. Okay. I said, does everyone agree? You said, uh-huh. Do y'all see that if I take this right here, plug into this, -1 plus root 3i, right? If I take that and plug that in right there, then I subtract -1 plus root 3i. They cancel each other out? Exactly. And you get a 0 here, wouldn't you? And that's what we were saying. We were looking for the zeros. What would I need to put into this one? X minus, no, we still use minus, always minus, just like we did the opposite of this. Then just plug in what? -1 minus root 3i. And see if I plugged in -1 minus root 3i right there. Do you see that this minus itself would cancel out and you get 0?
Does it matter where you put that I?
Which I? No, you can put it in front or in the back. So what I'm basically telling you is that if you just take this, put it in parentheses, put an x minus in front of it, you've done what you needed to do.
So that's what you need to do?
That would be a completely factored form. Right? I didn't ask you for that. I just asked you for the answers. I'm just saying, just keep this in mind, that we can actually take these answers and go back to the factored version this way. Does anyone have a question on what I did?
Do we need to know that?
Yes. That's why I'm asking you. All right? Let me give you another, let me give you a totally different example. Let me give you a totally different example. What if I told you to construct a polynomial with zeros, x equals 4, x equals 2i, x equals negative 2i. That's a weird I. I want you to construct a polynomial that has these zeros. So I'm going to create, what, 3 factors like that? What's going to go in the first factor? X minus 4, the opposite of what I see there. X minus 4. X minus the first one, 2i. Then x minus the next one, negative 2i. Like that. I want you to get into the pattern of, you're going to do x minus, that never changes. Then you're just going to put in the 2 different zeros in there. But when you do this, you can actually simplify it, because you have a double negative, don't you? Negative negative is really plus. Agreed? That is a polynomial, right? Sorry, I shouldn't have this equal to 0. Well, they didn't ask us to set it equal to 0, did they? No, they did not. This is the polynomial. Man, it was a good weekend, man. It was a good weekend.
And we could leave the answer as that, or we have to multiply it out?
Now we have to multiply it out. All right, because what we want is the original polynomial, not in its factored form. So we have to multiply all this out now. So what I recommend we do is take care of the stuff with the imaginary numbers first. And that means we have to multiply those, FOIL them together. Can you all do that? Can you do that on the side over here? Can you do this? What do you get here? Here to here? X squared, I'm going to put that here. Out in front of this, I still have the x minus 4. Okay, and then right here to here, plus 2ix. And then the middle one, minus 2ix. And those will cancel each other out. And now the last one, be extremely careful with this one. Negative 2 times negative 2, negative 4. And then I times I, which is I squared, which is negative 1. Why is it negative 1? Just the rule. So if we have this definition right here, that I is the square root of negative 1, then what happens if you square it? You square a square root, the square root goes away, doesn't it? So I squared is actually negative 1. Which means that this is actually going to turn into negative 4 times what? Negative 1. It's plus 4. So these are going to cancel. I'll just continue up here. I have x minus 4 times x squared minus 4 times negative 1. I'm going kind of slow on that. I squared is negative 1, so I replace it right here. And then negative negative is plus. So we have x minus 4 times x squared plus 4. Are we done? No, we got to multiply those two out. Are there any questions on how I got to that? Okay. Now multiply here to here. What do you get? That first multiplication? X cubed. Here to here. Plus 4x. Here to here. Negative 4x squared. And then here to here. 16. And then that's pretty much it, but we can put it in descending order, like highest power of x down. That is a polynomial function.
So we got to problem one.
It's close, isn't it? Or is that exactly?
That's it.
Hmm.
Maybe.
No, that's the second part from number one.
Yeah.
Is it? Okay.
Yeah,
So we get to
but it'd be times,
What do y'all think?
at least that some of the signs are opposite.
Tell me the truth.
Yeah.
good stuff.
Okay.
But I know you said that some.
May I erase? Anyone need this?
No, is it? I like how he doesn't even listen to me.
As soon as you said don't erase, I started erasing faster. All right. That, I just erased what I needed. What was it again? X cubed. What?
Minus 4x squared
Okay.
plus 4x minus 16.
Minus 16. All right. Let me show you something and see if you like this or not. What did we say the zeros of this were? When I started the problem, I said get to this, right? But where did it come from again? I told you x was 4, 2i, and negative I, right? Or negative 2i. So if I were to do synthetic division on this, right? This thing, what number would have worked?
Negative 4.
Negative 4? Was it negative 4? Would work? Was it positive 4?
4 would work.
4 would work. Okay. Because what were the zeros I told you again? 4, 2i, and negative 2i, right? That's what I told you. From that, we created this.
Yep.
All right, so let me just check that 4 would work. 1 comes down, 4 here, 0, 0, 4, 16, and you would have got 0, right?
Yep, and then it'd be x squared.
And then this would be x squared plus 4. We all see that, right? Where would we have gotten the 4 from?
Our list.
Our list, right? Our list would have been all the factors of 16, yes? Would that list of factors ever have created 2i or negative 2i? Would have never created it, right? Because we weren't even dealing with them, were we? But I wonder if those would work. Let's just look. I'm curious to know if I'm seriously not curious. I'm just curious because you're going to need to be able to do this in a minute. Okay? I'm just trying to get you to think a little bit here.
I'm curious.
If 4 works, right? If 4 works and gives us a remainder of 0, that helps us factor, right? But I wonder if we knew the zeros, if we could actually use those. So let's see. You bring down 1. This is going to get kind of messy. 1. What's 2i times 1? 2i. Uh-oh. Negative 4 plus 2i is what comes down, right? Negative 4 plus 2i is what's here. Yes? I mean, I can't put those together. It's almost like this is a real part and this is an imaginary part, right? This is what they come to be. What would the next thing be? This times this would go under here? This times this? I need to do that on the side. What would 2i times negative 4 plus 2i be? Do you understand what part I'm doing right now? This to here, I'm going to put that answer here. Distribute. This times this, negative 8i. Careful here. 4i squared, but what's I squared? Negative 1. So this would be negative 1, negative 4. Right? 2i times 2i is 4i squared, but that's the same as 4 times negative 1, so it's negative 4. So when I do this times this, I get, tell me? Negative 8i minus 4. So what happens when I add down here? 4 take away 4, take away 8i. What happens to those 4s? They go away and you get negative 8i. Do you all follow? What happens if I multiply 2i times negative 8i? You get 2i times negative 8i is negative 16, right? I squared. I squared is negative 1.
Or negative 1 minus.
Y'all are confusing me now. Do you all see this or not? Everyone? Look, that last multiplication, 2i times negative 8i, here, you wind up getting a positive 16 out of this, don't you? And that positive 16 goes here, and when you add down, you get 0. But this next part sucks because that's supposed to mean we're supposed to be able to write this as x minus 2i, and then what? X squared. Oh, man. Plus negative 4 plus 2ix minus 8i. Isn't that what that's supposed to mean? And what the hell is that, right? So this starts to get pretty ugly. Do you agree that gets pretty ugly? Yes? All right. But I wanted to show you that the synthetic division would still work. You'd still get a 0 as an answer, which does guarantee this, doesn't it? I mean, if this works, then that's a factor. Wasn't that one of our factors? Okay, just keep this all in mind as I'm moving ahead here. I'm almost done with what we want to do today. The last thing I want to talk about is what's called this is a theorem. In fact, the book says the conjugate pair theorem. A theorem is basically something that's just proven to be true, all right? Something that someone has proven is correct. If a plus bi is a complex 0 of a polynomial, then so is a minus bi. Always. What is this theorem telling you then?
That if you have a plus bi, then a minus bi is also there.
Yes. That's what it's saying. So elaborate.
Like,
Tell me in layman's terms, like not just what I put up there, just like in layman's terms.
if you have a 0 of a plus bi, you will also have a 0 of a minus bi.
Okay, so give me like a specific example. If,
The one we just did,
okay, the one we just did, what was one of the complex zeros we had?
a minus 2i.
It was 2i, right? It was 2i. What was also a complex zero?
Minus 2i.
Minus 2i. That wasn't just because I wrote the problem that way. The conjugate pair theorem says that guess what? All complex zeros come in pairs. Pretty much. It's because the plus or minus on that. Now, if what's underneath that root turns out to be 0, right? You don't have a complex number, then you get just one answer because plus or minus 0 is, but that means, that's right, this part of it would be 0 though. So it would be, yes, it's still a pair. That's right. All right? So everything's got to come in pairs. Everything has to come in pairs. Got that? All right, let's see if you really do get that. All right. if 3, 4, negative 2i, and 1 plus 3i are zeros of p of x, which or what are the other zeros? What are they?
-1 minus
So how about the 3? Do we consider the 3?
No.
No, because we could look at 3 as being 3 plus 0i, right? And then what would 3 minus 0i be? Same thing, the same number, 3, wouldn't it? So you don't even care, if it doesn't have an I, you don't even care about the pair part. But if it has an I, then you need to consider its conjugate pair. So what would the conjugate pair of this one be? Sorry, I didn't hear you. 2i? That would be 1. And then what about 1 plus 3i? What would its conjugate pair be? 1 minus 3i. Now be very careful here, okay? Because the real part doesn't change. Only the sign, these signs have to be different. Understand? We're good? So that would be those are the other zeros right there. All right. Find an example of a degree 4 polynomial with zeros 1, 2, and 2 minus I. So I want you to give me an example of a polynomial that has degree 4 and has those zeros. There would be one more zero. So you have to know the conjugate pair theorem, which tells you that there's actually another zero here. What's the other zero? 2 plus I, right? And then what I can do is I can construct the polynomial knowing that I'm going to have a total of how many of these factors? 4 of them, right? Using 1, I can do the opposite, x minus 1, 2, x minus 2. Hold on, Lily. Hold on, Lily. Everyone else has to keep up with Lily here. How are we going to put this in? Like we did the x and then we did minus 2, right? So how are you going to put this one in? X minus what? Parenthesis 2 minus I, like that. Same thing with the other one. X minus parenthesis 2 plus I. Now we get to multiply this all out. All right? This part of it, are y'all okay with this part of it? Just you use the conjugate pair, and then you just plug them in. Is that part okay? The multiplying out is going to be a kind of mess. But we've got to figure out how in the hell we're going to multiply these two together, because this is the part that's a little tricky. All right? Do you agree these two together aren't that bad? Okay. So let's try this out. I'm going to do this kind of like scratch work. I'm just going to do these two right now. All right? Yes? This would be like what? There aren't any like this on the review yet. No. The review didn't have any of this. Yeah. Remember, the review is not exact copy of the exam. So I could ask a question like this. Yeah. Yeah. I think the first exam was pretty much a copy of the review. But I don't want you all to go into this one thinking, oh, it's going to be an exact copy, and then when I give a problem like this, you're like, that wasn't on the review. I'll say, I did it in class, though. All right, so I'm going to multiply those two together, just these right here. So let's try this, because we've never done this before as a class, right? We've never actually gone through this. I'm going to do x times x first. That's the easiest one, right? X squared. All right, now think about this. When you do the next multiplication, it'll be x times that, right? So tell me what I would get. I would get 2x plus ix, right? But subtract. So minus 2x minus ix. Isn't that what that would be? What's x times 2? 2x. But then subtract it. What's x times I? Ix. But subtract it. Yes? Okay. What would I get on the next one? Here to here. So what's 2 times x? That would be 2x, but then minus. So minus 2x. And then ix. I times negative x is negative ix, but then minus, so plus ix. Everything cancels there, or no? Just the ix's. Still got to do the last one. Are y'all okay with that, though? That part? The two inner ones? Okay, the last ones I'm doing, it's basically this entire thing right here times that entire thing. This one is a negative, isn't it? This one is a negative. Negative times negative? Positive. And then 2i, we have to do 2 minus I times 2 plus I. Right? So can you do that little thing here? What do you have? 4 plus 2i minus 2i, and then the very important one at the end, negative I squared. But I squared is negative 1. So plus 1. So that's 4 plus 1 over here, which is 5. So 5. All right, let's cancel things out here. We've got the ix's are gone. And that's it. So these two together right here turn out to be x squared minus 2x plus 5.
Actually, it would be minus 4x.
Yeah, man, I don't know where my brain is today. It checked out. Well, it never checked in today, I guess. That's just these two together, right? Then we have to do, what, do you want to do these two together now? That's a lot easier now, isn't it? Like this compared to these two? If you do those two together, minus plus 2, right? But then you have to put those two together. Are there any questions on what we're doing? How do you go about multiplying two trinomials together like that? Do like a foiling almost?
First times them all, second times them all.
Yeah, this first one times every one of them. And then the second one times every one of them. And then the third one times every one of them. So you're going to have a total of 9 multiplications here, and then you have to collect everything together. Don't get mad at me. I don't make this up. Just the messenger. So what do we get? X squared times x squared. X to the 4th. Next one, x squared times negative 4x is negative 4x cubed. X squared times 5 is 5x squared. negative 3x.
minus 15x, plus 2x squared.
It's a mess. 9 things, right? 12x squared minus 15x plus 2x squared minus 8x plus 10. Then you collect all your like terms together. Let's see if we can do that.
X to the 4th minus 7x cubed plus 19x squared plus 24x plus 10.
It's what? Minus what? Minus 23x? Okay. We all on board with that? Like some other confirmations? That's it. We found a 4th degree polynomial that had the zeros that were given to us. 10. That's it. That's it. Remember, in the very beginning, it said find a polynomial that has these, a 4th degree polynomial that has these zeros. All right, let's do one last problem. You don't think what?
Said I don't think the fish is gonna come off.
Oh, what was I doing? This? I'm kind of spaced out a little bit today. We're done. Well, I want you to at least see an example of the problem you would see on the test, right? I mean, yeah, but one more. All right, one more. So I'm going to do the 12th one on this review. So given x equals 4i is a solution to this equation. You all have this in front of you, right? Find all the solutions. Is everyone ready? Deep breath. Okay, so you're going to have a conjugate pair here, aren't you? You will have a conjugate pair because if x equals 4i is a solution, x equals negative 4i has to be a solution by the conjugate pair theorem. So let's just keep that in mind. X equals negative 4i is also a solution. So I already know that. How many solutions total should I have? 4, right? Some might repeat though. How many solutions do I have so far?
2.
I have 2 of them, right? I have 2 of the 4, so I only need to go get the remaining 2. But that means I'm going to have to be able to somehow break this thing down, right? You want to do synthetic on the number 144? We could. We could, couldn't we? We could?
It's only going to go up to 12. I mean, is there a better way of doing it?
Well, that's what we need to consider. What are some ways that might be a little more efficient? Synthetic division is always pretty good. Let me see if you agree with this. This should factor to be 4 things, yes? And I know that 2 of the factors are x minus 4i, that's from here. And this one is x minus 4i, so x plus 4i. Do you agree?
What if you like multiply those together?
Yeah, what would happen if I did multiply these 2 together? You get x squared plus 16. Now I'm not doing that because it would just be foiling these